All right, so let's go ahead and talk about PA5. So I posted PA5 last night. I just made a few typo corrections a little while ago, so there's a new version of it up, but nothing too critical. All right, so PA4. First of all, really good work with that assignment. Um, Lots of good approaches, good designs for your programs, and good implementation. And what you probably discovered in PA4 was that there were a lot of things that didn't necessarily take a lot of lines of code, but you had to get those lines just right. Right? You might want to, open a dialog box and get information from the user and use that to find a date in your list of appointments and then delete it. And each of those steps might be one line of bash, right? But knowing exactly which line of bash and what to put on that line was probably where a lot of the challenge was. And so this is pretty typical for bash programming. We have, at our disposal everything that is Linux, all of the commands that are available, all of the built-in stuff for bash, loops and conditionals and things like that. But we got to figure out how to use them. And so PA5 is going to be more of that that experience where we're going to write a fairly powerful program, a utility that takes a set of input text and basically tells you how many times different phrases appear in that input. A fairly powerful function. But if we do this right, we're not going to have to do too much complicated programming. We're not going to have to write, hundreds of lines of code to do this or that. We're going to use built-in utilities from Linux to do most of that grueling work for us, and we're going to be mostly putting together the pieces to get what we want out the other side. So we're going to make a few passes through this description of PA5. I'll give you a kind of top-level view of it on paper, just so we kind of have an idea where we're going, and then we'll start digging through the details of the assignment here, and then we'll keep digging deeper and deeper into more of the specifics, and that will probably take us through today, and then we'll start going into some of the aspects of Linux and Bash that will help us do these tasks in a reasonably manageable way. So let me start with a very high-level view of PA5. The goal is to take a set of input text and break it into phrases. So break it into sets of words separated by punctuation usually. And the goal is to produce, at the end of reading all the input, a tally, right? A list of the phrases we found in the input and how many times each phrase occurred. All right, so what does this mean in practice? Let me grab some sample code. So you're going to write a script called main. And let's suppose you say, hello, this is a test, cool, hello, cool, this is a test. And I spelled the last one wrong. So there's my input, right? I'm going to hit Control D to signify the end of the input. Here's the output I get. I saw the phrase hello 3 times. I saw this is a test once. I saw misspelled this is a test once. I saw cool twice. Okay, that's sort of the first order setup. But it's more sophisticated than that. So I can say hello, this is a test. Cool, hello, question mark, this is a test. By exclamation mark. And it will still do a reasonable phrase of saying, okay, I saw hello twice, I saw this is a test twice, I saw cool 2 times, and so on and so forth. I saw haha once. So if I do this on War and Peace, which is a fairly long set of text, right? So here's what War and Peace looks like. And it's a pretty big document. So it's 63,000 lines of text, 3.2 million characters, right? So this will take a few minutes to chew on, but when I'm done, I should see all the phrases contained in here. I am very sorry to leave your enchanting party. That's a phrase. That should appear in my final tally. Said he is a phrase, right? Very lovely is a phrase. Very is a phrase. So my goal is to read all of this input, break the input into these phrases, right? Things separated by punctuation, and then count how many times each of these appears. This is going to run for a few minutes, I think.
Still faster than I could read War and Peace.
Yeah. So yeah, I'm not actually taking that much CPU time. All right, so how do we do this? I'll let that run. It's fun to see what these look like. So at a top level, we can view PA5 as 3 steps. Read some input, clean it up, and break it into phrases. And then count, or I'll use the word tally, count how many times each phrase appears. And then print the results, print the final tally. All right. So let's go through this document once, and we'll skip over some of the details, but let's hit the highlights on here, okay? So you're implementing a bash script named main. It's got to be written in bash, got to be named main. It reads from standard in, breaks your input into phrases, counts how many times each phrase occurs, and at the end of reading all the input, prints out a list of phrases along with a tally. And running my test program here, I said main less than and the name of a file, so standard in is coming from this file. And standard out is just going to spew out on my screen, but if I did a greater than, then I could send the standard out into a file, and so on and so forth. Alright, critical requirements. Your program has to run on the Linux server, has to be a bash script. You can use sed, awk, tr, which we'll talk about today. All of these utilities, you can use the built-in capabilities of bash. So you can use if statements, while loops. We're going to talk about something called a for-in loop, and you can use that. Arithmetic operations, we're going to talk about associative arrays, and that's going to be a big part of this. Variables and all kinds of stuff like that. So all the usual stuff you do in bash programming, you can use in this assignment. You should test your program thoroughly on your own input files. So do, some little tests like this. This is a fairly easy test to pass. This one's a little more complex because you've got multiple phrases on one line. This is going to be a really hard test, right? For no other reason, because it's going to take so long to run. I might not let that finish. So you want to test your code as always. But when you think you've got your code working, you can find some sample test files on the server. So go under /temp/pa5, assuming you can type. And there's a series of test files here. There's test0 through test4.in. And each of those should produce output as described in test0 through 4.out. So test0.in is, you know, a few phrases on a line, a little bit of tricky punctuation, some extra spaces, and so on and so forth. Test1.in is a little more complex. Test2.in starts to get into some weird punctuation stuff that we're going to talk about how to deal with. And test3.in gets really crazy with lots of strange, you know, punctuations like that and this and so on and so forth. And then test4.in is a big test file. It's not as big as War and Peace. This is Wuthering Heights, but it's a 2,000 line file, so it will take about a minute to run on the Linux machine. All right, and for each of these, there's an output file that shows what your program should produce for that corresponding input. So test0 should produce this output. Test1 should produce this output, and so on. So you have at your disposal a bunch of test cases, including 5 test cases I plan to run your program on. So as you're developing this, right, you should be testing it, you know, with your own sample files. But as you start getting closer to where you think you're satisfying all the requirements in this write-up, you can start running it against these test cases on the server from this directory and double check that your understanding of what it's supposed to do is correct. All right, there's very specific rules. A lot of this document is about how to clean up the input, what we mean by a phrase, how to break your input into phrases, right? So we're going to go through all of that in detail today. But we're also going to go through some bash code that you can use to actually do this input cleansing, this breaking into phrases, and so on. All right, so your program reads from standard in, produces output to standard out, and it does not do anything else. It cannot prompt the user, it cannot print status messages, it can't print a message at the end saying, you know, your file was X number of lines, or I found this many phrases. It's got to do exactly, just read from standard in, produce the tally to standard out. So for example, if I say main less than test3.in, oh, on the wrong machine. If I do main less than test3.in, this is what it should produce. And this is what the input file was. So there should be very few surprises when you submit this and you get your grade back, right? You should be able to predict what your grade's going to be. Which means if you leave yourself enough time to do this and you come in and ask questions far enough from the deadline that you can work with the answers, right? You should be able to get 100 on this assignment and come out with a really solid understanding of some pretty important bash concepts and computer science concepts. All right, so we'll skip over the input processing and phrase building for now. We'll come back to that. There's what we just talked about the test program. And if you want to use these test files, what you want to do is run main less than test file name, but take the output and do a sort-n. That will sort it numerically based on the number of times the phrase appears, and that will give you output that should match character for character these output files. Right, so I've basically done this command under /temp/pa5. So if you do this in your own directory, your test0.out should match exactly what's in /temp/pa5/test0.out. All right, to submit, you make your script. Make sure your script is called main. Put it in a subdirectory called pa5 under CSE224, and make sure it's pushed to Git by the deadline. This is due a week from Friday. So that's November 26th. So you've got over a week and a half right now to finish this. But that Friday is the Friday after Thanksgiving, right? So if you're taking Thanksgiving off, right, then change the deadline for yourself. Make this due Wednesday, a week from tomorrow. Make it due Tuesday, a week from today, right? But do something with your schedule so that you have this submitted on Git by the 26th. All right. So grading, to get any points, you've got to satisfy these minimum requirements. It's got to be a bash script. It's got to be submitted on Git by the deadline, unless you use slip days. It's got to run on the Linux server, so make sure you test it on the server. It's got to work for more than just the test cases. So you can't just, hardwire those 5 programs to produce the right output. It's obviously got to work for, any input file. Should read from standard in, write to standard out. Hey, War and Peace just finished. So there's the tally of phrases in War and Peace. And there's quite a few. And a lot of these phrases only occur once, or even occurs 3 times. Chapter 30 occurs twice, probably once in the contents and once at the beginning of the chapter. That person appears 3 times. Intrigue is 23 times, said Nicholas. There you go. He must be teaching a class or something. How is appears 4. So that's that's a big long test case. But these are the ideas of what phrases are, right? They're basically things between punctuation marks. So his left eye gazed, taking your arm led her out to the veranda, and so on and so forth. All right, it's got to read from standard in, write to standard out, and it should not error out partway through. I heard Nicholas is at the cutting edge of this difference engine from England. Awesome. All right. Assuming that you do these things, you get points as follows. If your script is named main, you get 5 points. So you got 5 points for free, right? Just call your main script main. As long as it reads from standard in and produces some sort of output to standard out, you get 15 points. Right? So a talking cow telling me my fortune would get you 15 points still. All right? So you got 20 points without really having to do a whole lot of work. If the output format is correct, and the correct format is, it should be a number followed by a space followed by the phrase. And it should just be, one of these on each line. So number, space, phrase, number, space, phrase, and so on. 30 times she asked. And when you sort this, it's fun because you get your most common phrases at the bottom, so you can see like what's said most in your text. All right, so output correct format, 5 points. No extraneous output, 10 points. Right. So there's a handful of points, 35 points that you can get without really doing anything with associative arrays or tallying phrases. All right, then we get into the tests. So those first 4 tests are worth 10 points each. So if they work perfectly, you get 10 points each. If there's an error with how you process the input, if you didn't get rid of the characters you were supposed to get rid of, or you didn't break your phrases up correctly or something like that, you can lose 5 points for each test where that happens. Maximum 10 points per test. And then test 4, which is the longer one, is worth 5 points. And on the Linux server, when I ran my script, it took about a minute to produce output. So you got to kind of be patient with that one. And I'll be patient when I'm testing it. All right, in the beginning of your main script, after the shebang, you got to have a block of comments that have your name, the date, and a description of the project in your words. Don't just say word tally program. You got to describe it in detail. Right? Enough so that somebody looking at this would know what the heck they were looking at. Okay, that's worth 10 points. And then you need documentation throughout the code. So your code has to be formatted in some kind of consistent way, indenting and so on and so forth, and broken into sections, right? There's going to be at least, some logical sections. We're cleaning our input, we're breaking into phrases, we're tallying how many times it occurs, we're printing that tally. Each of those sections should be set off with a block of comments saying what's going on in this section, what are we doing now? And the individual lines of your script, if it's not 100% crystal clear what you're doing, you better have a comment on that line. And if you go back and you look at your dialogue program, each line in that program probably did a bunch of stuff. So you want at least, one comment corresponding to each line, but possibly, a block of comments. Like, next we're going to take the input and we're going to get rid of all the punctuation marks by changing them into @ signs and then removing those. And then you have a big long line of bash code that does that, right? So lots of commenting. All right, ideas for succeeding on this assignment, right? Most important thing, start early. Okay, you've got, over a week and a half. Do not wait until, a few days before it's due. For one thing, I don't have office hours, right? That's Thanksgiving. So I don't know if I listed hours for Wednesday. I definitely don't have hours Thursday and Friday. So start early, right? And like I say, if you're planning to take off Thanksgiving, put an artificial deadline on yourself and say, I'm going to have this done a week from tomorrow, right? And just plan on getting it submitted by then. I got office hours, every day, Monday through Friday before then, and so on. All right. If this seems like, I could do this in my sleep, right? This won't take any time at all. Go ahead and do it right now and get it out of the way. Don't ever, personal suggestion, if you got something that seems really easy to do, don't ever put it off and say, that's not going to take me any time. I'll do that, next week. Do the easy stuff quickly. Get it done. Get it out of the way. And then you don't have to think about it, and you're done with all of your programming assignments for 224. If it seems complex, that's an even better reason to start early, because it's probably going to take some time, right? And you don't want to be slammed at the end, with a deadline coming. This does not involve a lot of really gory, deep, complex, nested loops with, huge if statements and things like that. It's mostly a bunch of calls to Linux programs, to sed, tr, and it's careful use of associative arrays, which we're going to talk about. But when you get this done, you'll look at it and you'll say, that's not a lot of code, right? That does not mean it's easy. It's not easy. It's going to take a lot of work to figure out how to do the things you have to do. But once you've done that and you look at it, your code's not going to be that long, right? But that's the thing with Bash. You can have 10 lines of Bash code that does amazing things, right? And might have taken, quite a bit of time to construct. Right? So start work on it early, and break it into pieces. So if we think of this as, first we're going to read some input and we're going to clean it up, and then we're going to break that input into phrases, and then we're going to count how many times each phrase occurs, and then we're going to print out a final tally. Well, we've got 4 fairly separate pieces to our project. And you can spend, your first few days just cleaning up input. Just write a program that reads from standard in, does what we're going to describe when we say cleaning up input, and generates output. And once that's working, now you're working on something that takes cleaned input and breaks it into phrases. Well, that's easier than taking arbitrary input. If I've already converted all my characters to uppercase, and I've gotten rid of special characters, and I've gotten rid of multiple spaces, and so on and so forth, breaking that into phrases is going to be pretty simple. So I'm going to do this first. I'm going to cleanse my input, make it look like I expect, and then I'm going to take that cleansed input and I'm going to break it into phrases. Well, now I have a loop, and each time I go through this loop, this variable has a new phrase in it. So now I don't have to worry about this. All I've got to do is inside my loop write some code to say, hey, I'm looking at this phrase. Have I seen it before? If not, let's remember it. If I've seen it 5 times, let's make a note that now I've seen it 6 times. And that's going to be like 2 or 3 lines of bash, right? But only if I'm concentrating on, you know, I've got a phrase and this bash variable called phrase maybe, and I want to tally it. If I'm trying to do that while I'm also trying to break things into phrases and convert things to uppercase and get rid of special characters, I've got a big mess on my hands. So you really want to break this into pieces. And if I'm doing all of this and I've got an associative array with all of my tallies in it, now I can say, how do I print that out? Well, that's going to be like 2 lines of bash code. So you really want to be breaking this into pieces, right? Don't try to do the whole thing. And this also goes along with starting early. If you've only got 2 days to do this, it's very hard to resist the urge to just write one big long script that does everything. If you're starting early and you know you've got a week and a half, it's more comfortable to say, I'm going to do this small piece, then I'm going to do that small piece, and so on. And before you know it, you've got all the pieces done, you put them together, and you're finished. Alright, so start early, leave yourself time to, you know, recognize missteps and go back and start down a different path. Leave yourself time to come in and ask questions, right? Get used to trying things on the command line. So one thing you may have noticed in PA4 is when you're writing your script and you're trying to delete an appointment, right? You keep trying things. Well, you have to go into your big script. You have to get down to the delete section. You have to put in your new idea for how to delete. And then when you run your script, you've got to go through all the dialogues and say, you know, I'm looking for an appointment, it's on this date, here's the description, I want to delete it, right? That's a fairly cumbersome development process. And the line of code that you keep changing in your script is something you can be typing on the command line, right? So you can just run bash and you can type, you know, bash commands. And I could say, you know, read appointment and go to store, and I can say echo $appointment, and I could say grep $appointment, you know, in my file, and if I had an appointments file in here, right? And I could see if this grep command is working, and I could do grep-v and see if that's working. And I could try to redirect that to another file. And if there's a problem with how I'm using these commands, I would see it right here. And you can do much more rapid prototyping from the command line than going into a script and forcing yourself to go through all the stuff in the script up to the point that you're working on. So get comfortable with this idea of working from the command line and trying things out. All right, ask questions early. If you have no idea how to start, come to office hours tomorrow, and we'll start going through some things together, right? All right, and there's some sample code in here. We're going to talk about associative arrays in a little bit. We'll talk about cleaning the input and breaking it into phrases first. And tomorrow we'll definitely talk more about associative arrays. But here's some sample code that you'll want to play with from the command line and get comfortable with and see what it does. And we'll go through all of these things in class together. But some of this will end up being part of your PA5 in some way, shape, or form. When we want to print out the final tally, it's probably going to be this. It's going to be a single for in statement, a do, an echo statement, and a done. When we're trying to see if a phrase is already stored in our tally, it's going to take a single line of bash and an if statement, right? Something like this. All right, so let's talk about input cleansing. And the idea here is, you know, here's the phrases that it ended up with from War and Peace. But here's what the original input text looks like. It's uppercase, it's lowercase, there's quotation marks, there's blank lines in between paragraphs. There's all of this other stuff in here, right? And when we get our final count of how many times things occurred, we, want straight out with an uppercase S to get counted the same as, straight out with a lowercase s. So one thing we're going to do is we're going to convert everything to uppercase. All right, so let's start writing a little division of these tasks. So cleaning input. And maybe we don't have to write it because it's actually in the assignment. Cleaning input. So first thing you're going to do is convert all your letters to uppercase. So we're going to ignore case. Everything's just going to turn into an uppercase. All the phrases we spit out at the end will be uppercase. And this is really easy to do in Bash because there's a command called tr, which is translate. And I can do the following command. I can say tr space quote A through Z quote uppercase A through Z. And this will read from standard in. And it'll convert everything to uppercase. And if there's things that aren't letters, they just get left unchanged. So punctuation marks, numbers, and so on. And uppercase letters don't get converted, they just stay uppercase, right? So that's one line of Bash. Convert from lowercase to uppercase. Really easy to do.
So if you did it the other way around, it would go everything to lowercase?
Yep. If you do uppercase AZ, lowercase AZ, it converts to lowercase. So if I cat War and Peace, it's all of this stuff. If I take that and I pipe it into tr A through Z, right? I've got an uppercase version of War and Peace. So that's the first step of cleaning up our input, make everything uppercase. The next step is to get rid of special characters. So all these characters, we want to ditch them. And there's a few ways we can do this. So we can use sed. Remember, sed, the basic way it works is substitute slash thing we're looking for slash the thing we want to replace with. So if I substitute slash parentheses with nothing, this should get rid of all of my parentheses. Right, so that got rid of all of my left parentheses. If I wanted to get rid of right parentheses, right, I could do this. But I recommend a trick in here, which is to use tr together with sed. So we could use tr and change a bunch of characters to a single symbol, and then just get rid of that symbol. So I could say tr parentheses get changed into an @ symbol. Right? And then if I take the output of that and I pipe it into sed and I say substitute the @ symbol with nothing, right, that basically gets rid of my parentheses. And I can put multiple symbols in here.
So you can put as many symbols as you want as long as it's between the single quotes?
Mm-hmm. Yep. As well as things like, A-Z or 0-9, it understands that this means a range of characters. So for us, it's just going to be a bunch of characters. And this is yeah, so someone asked in chat, why not just use sed? So you can use it in sed, but then you got to deal with getting rid of square brackets and escaping those and so on and so forth. If you want to do it in sed, that's totally fine. That's a more direct way. But this is also a way to do it. So, and this is, you know, something you can play with. We just played around with this on the command line. I didn't write a script. I didn't have to go through a bunch of input prompts, right? This is what I mean by sort of, you know, doing rapid development from the command prompt. And, you know, we also want to get rid of this single quote. And so if I try to, you know, tr single quote and replace that with an @ sign, that's not going to work. And if I try to do tr double quote inside here, that's not going to work. But I can, instead of using single quotes to enclose my string, I can use double quotes, and I can do this. And now it replaces my single quote with an @ sign. And I can take this and I can pipe it into another tr, which replaces my double quote with an @ sign. And now I can replace single and double quotes. Right? But this is the kind of thing that, you know, you can try 100 different experiments in 15 minutes from the command line. If I have to go into VI and edit my script and change my command line like this and then run my script again, I'm going to get through, you know, like 5 experiments an hour maybe. And I'm going to make mistakes on the way and mess up my file and so on. So command line is your friend, right? Try stuff. And this is the preferred way to learn how to do things in Linux. You can go to Stack Overflow, right? And you can search for getting rid of quotation marks in strings in Bash. And you'll find lots of ideas. And those ideas will often work. And they're not going to teach you a single thing about Bash. They're going to give you some code that lets you get rid of quotation marks in a string in Bash. You're not going to learn anything about Bash by doing that, right? You do this, and this, and this, and this, and you're going to learn a lot, right? And that's what we're after here. So it's going to be a small set of tools, sed, tr, that may be all you need as far as commands, and then associative arrays. All right, so that's our second part of cleaning up input, is changing these things into @ signs, and then we can do something like we can get rid of these things and compress them to we can get rid of these by putting them into sed. And now if we do something like this, right, it's totally cleared out our punctuation. So that's part of cleansing the input, and then maybe take all of this and put it into tr like that. And notice what we're doing here, though. I mean, we're executing 1, 2, 3, 4 Unix commands, piping them all together. But look at what we're doing here. We're taking something with upper, lowercase, and punctuation marks and so on, and we're cleaning it up into a nice, clean phrase. All right, so that's the second part. Third part is take consecutive spaces, collapse those into a single underscore. And there's a sed command for doing this. We have to talk more about sed still. But if I say sed, substitute slash, and here's the special part, space, followed by space asterisk, slash underscore slash g. What this is the start of a regular expression, which we're going to talk about regular expressions later. But this is basically saying, look for a space followed by 0 or more additional spaces. So this will take any collection of consecutive spaces and change it into a single underscore. So now I've taken my input and, you know, assuming I've converted it to uppercase and all this kind of stuff, right? It looks like this. It's all one big long thing without any spaces, but I know where the spaces were because I've changed them into underscores. All right, so this said line is pretty magic. S/space */*G. All right, now we look for phrases. We've got our input cleansed. We want to break it into phrases now. Well, phrases are things that are separated by these characters. And so we're going to find any of these characters, we're going to change them into a single space. Well, we already know how to do that, right? We could do something like take each of these and change it into an @ symbol, and then change any run of @ symbols into a space. And the end result of all of that is the following. Let's say your input looks like hello, comma, this is fun, ! Why, ? Why not? 3 exclamation marks. Bye, period. And it will turn it into the following. Hello followed by a space. This underscore is underscore fun followed by a space. Why followed by a space. Why underscore not followed by a space. And BYE. So that's your goal at the end of your input cleansing, is to take input like this and turn it into something like this. And you're doing this for 2 reasons. Number 1, because, you know, all of your phrases look the same. If I say Y in all uppercase, or I say Y with an uppercase W, they're all going to change into the same thing. The weird punctuations like triple exclamation marks have gone away and so on. But also, each of these phrases is separated by a space. And so now I'm going to have a input line that looks like, you know, 5 things separated by spaces, and each of these things is a phrase. And that's a really good setup for extracting phrases from our input line. And so here we're going to use what may be a new bash construct to you, which is a for in loop. And this is a for loop that you're welcome and encouraged to use. Let me show you the general setup of a for in loop. So let's read an input line. Hello, this is fun. Goodbye. So here's what my input line is, right? So let's say I want to do something with each piece of this variable's value. I want to do something with hello, and this, and is, and fun, and goodbye. All right, so we can do this with the following structure. For, let's just say word in $input line, do. And now I can do whatever I want in here. I'm going to say word equals $word. And I'm going to say done. Alright, this is like a for loop, but instead of iterating a variable, an integer from one value up to another, it's going to look at this input line variable, this thing with 6 words separated by spaces, and the first time through it's going to set this variable word equal to hello. And it's going to do whatever's in the body of the for loop, which for us is just echoing the value of that variable. And then done goes back up here and it will set word equal to the next word on this input line. And we'll echo that out and so on. So if I do this, my loop iterates 6 times, and each time through my word is the next piece of this input line. So if I do that kind of for in loop, but I do it on a line that looks like this, the first time through my variable is going to be equal to what? My first phrase, hello. The next time through the loop, it's going to set my variable equal to what? My second phrase, this is fun. And then why not, and then bye. So this first of 3 steps in PA5 is basically take your input, clean it up, put it into this form, and then use a for-in loop to basically pull out each phrase one at a time. All right, that's this piece. Once you do that, you've done. You've cleaned your input and broken it into phrases. And then the second step is for each phrase, let's go ahead and tally it. Let's record how many times each phrase occurs. All right, that's what we're going to start with tomorrow, and that's going to take us into something called an associative array. And this is like the best tool you'll ever encounter in a programming language is associative arrays. They're like super powerful, and we can use them for all kinds of things, including pretty painlessly counting how many times each phrase appears in our input. So we'll talk about associative arrays in detail tomorrow, and that'll be the section on building the tally and post-processing. And again, this is going to be, you know, a few lines of bash once we know how to do it. All right, so we'll start from there tomorrow. We're out of time today, so have a great afternoon, and I will see you tomorrow.
But did we ever do an attendance thing?
No, I'm not going to worry about it today.
Okay. All right, thanks.
All right, see you tomorrow.